Give me the problem. All right, I don't mind doing this as long as you pay attention.
Okay.
All right, give me the problem.
In parentheses, negative 11 plus 3i.
All right, tell me what's the operation? Addition, right? How do I know that it is an addition and not a multiply? Right? So let's just combine like terms. I have negative 11 and positive 9, which would give me negative 2. I have 3i and 2i, which would give me Gucci.
Okay.
Wow. Okay, so give me the problem. This is number 3, so be very careful with your subtraction because when I subtract, it's distributing through the entire set of parentheses that follow it, right? So really, and sometimes it might help you to rewrite it. 7 minus 2i minus 2 minus 6i, and then gather your like terms. I don't know what number this is. Yes, this is number 3. So 7 and negative 2 is 5. And negative 2i and negative 6i, that's only when you multiply. If you add, if it's just combining like terms, that's all it is, when you add or subtract. 7 and negative 2, and then negative 2i and negative 6i. You still add them. Okay, give me the problem. All right, again, when I'm subtracting a complex number, I'm subtracting everything in those parentheses, right? So this is 6i minus 14 plus I plus 5 minus 3i. Gather together what goes together. So the whole numbers first. Negative 14 and positive 5 gives you what? Negative 9. Then I have 6i, I, and negative 3i, which gives me what? Positive 4i. Okay?
Wait, you not
Oh.
Wait, no. I got number 9 now. But number 10,
Somebody said 6 before 9. Okay. Wait, say it again.
The negative I is on the outside.
Oh, okay. It's not multiplying. It's just combining like terms. Yeah. Four. Yes. All right, number 6. You said it's negative I, parentheses. All right. I'm going to distribute this through. Negative times a negative is a positive. Here's where I need my square. Huh? I haven't yet. Right now, I just changed the sign because a negative times a positive is a negative. Well, now I'm going to change it. Now, this is a positive 10. So it's going to be 10 plus 2i.
Doesn't matter what goes first. Doesn't matter what goes first.
Standard form is the number plus the I or the number minus the I, but it doesn't matter. No. All right, number 10. That's exactly right. Why did you do that first? PEMDAS, order of operations. You're exactly right. Multiplication comes before addition or subtraction. So the first thing I'm going to do is multiply these two out. Y'all okay there? It's a FOIL situation, right? 9 plus 3i. Now I'm done with this one. I'm going to move on to the 7 and distribute it through. 7i. 7i, 63i, I squared. And I'm with you. I'm just going to ignore that part on the end right now until I get this first part situated, okay? And then I'll worry about it in just a second. All right. So 2i squared negative, oh, it is 21. I left the 1 off. Negative 21, right? Because I got to change the sign because of the I squared, right? All right. Now, whole numbers, I have a 9 and a negative 21. Yes? 3i and 63i. Now, I'm not done with this problem because remember this? Minus 4 plus 2i. I'm changing those signs. So now I've got negative 16 plus 66i minus 4 minus 2i. You don't have to. I'm just trying to slow it down so you see what's going on. Could you what? Say again? I did, yeah. So negative 16 and negative 4 is negative 20. 66i and negative 2i is 64i.
I got negative 16 plus 64.
What happened? Oh, y'all gave this to me after you had already combined it with the, no. What's negative 21 plus 9? Negative 21, negative 11, negative, it is negative 12. And then negative 12 minus 4 is negative 16. Yeah, sorry. Yeah. I listened to y'all. I said, what's 9 minus 21? Y'all said negative 16. I said, okay. I didn't even stop to look at it. Huh? It always covers what wasn't covered before. It starts with radicals. Solving with square root. Give me another one from your homework.
Flip to the back and the whole back.
All right, give me one to start with. 8.
No, we're doing all of it.
8 plus I.
8 plus I.
All right, so FOIL. These are conjugates. Remember we talked about conjugates, so you're exactly right. The I should cancel out whenever I multiply these. 8 times 8 is 64. Minus 8i plus 8i minus I squared. That's right.
You added this I square
Say again? It makes it -1. So if it was already negative, it would become +1. You could. You could. Well, all right. Shh, shh, shh. Stay focused, people. Stay focused. All right. Give me one. All right, so my first question is, what am I dividing by? Am I dividing by an imaginary or a complex? Imaginary. Why is it important that I know what I'm dividing by? It's different, right? You need to know what you need to do. If I'm dividing by imaginary, then I'm just multiplying the top and the bottom by I. But if I'm dividing by a complex, that's whenever things get hairy, right? I got to multiply them by the conjugate. So here, this is an imaginary. Do you agree? So I'm just going to take an I to the top and the bottom. Up top, I get 10I, yes? Over 2I squared. So this becomes -2, yes? What is 10I divided by -2? -5I. Yes, no, that's it. Yes, you need to simplify that if it says that way. That would be partial. Yeah. That's correct. Just stay in fraction. All right. Somebody said 14, so I'll do 14. What's 14 say? Imaginary or complex in the bottom? Imaginary. So all I need is an I. The top, it doesn't matter what's in the top. It only matters what's in the bottom. If that had been a complex in the top, still same thing, just I. I only need to get the I out of the bottom. That's it. Yeah. Yes. All right, so I have 4I over -9I squared, yes? -9I squared becomes +9. So now I have 4I over 9. 4 and 9 do not simplify, so I leave it as is.
Are we actually going through the entire reaction?
No. Yeah, let's do 20. I promised. 20 next. Give me the problem. That's exactly right. How do you know that that's what you need to do? And the denominator, and that's important. So did everybody hear that? The complex number is happening in the bottom. The top doesn't matter. So since there's a complex in the bottom, I'm going to multiply the top and the bottom by the conjugate of the bottom. That's exactly right. I'm in a double FOIL situation. Right? Nothing to it but to do it. Let's just get through. I get 2 over I am lazy and I don't like to rewrite stuff over and over, so I come here and I just go ahead and change everything that needs changing. These cancel, right? So in the bottom, Tyler says we have 20. That's exactly right. How about up top? Yes. That's exactly right. I was waiting on somebody to say that because I knew y'all were going to see that you could simplify that. So listen very, very carefully. As you simplify fractions that have multiple operations in them like this, if I want to simplify whenever I have complex and imaginaries, I have to divide every single term in there. So I could divide everybody here by what? 10. So to simplify, -3 plus 2i over 2. Don't have to pull up. If it says simplify, but we'll focus on that. I don't remember what 18 was. Yeah. Didn't I do 18? I don't know. All right, yeah, what's your question? Because anytime you have a complex in the bottom, you have to change the sign when you multiply. That's the only way to get the i's to go away. Can't have a square root in the bottom and an I is a square root. When you multiply conjugates, i's go away. Well, what's 8 minus 8? Right. So what's 8i minus 8i? 0i, and 0 times anything is, which is still 0. I don't know. No, you won't. Yes. Yes. Yeah. All right. Do y'all have any other questions about this one before I move on? Yeah. Yes or no? Shh, 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 shh. I'm going to do one more, and then I'm going to do something that we haven't done. I'm going to give you about 5 minutes to talk about the rest of them with the people beside you to check once I clear up a couple questions. So, yeah. I don't know. How you know? You always know? Do you know for real? I think it is. Yeah. Yes. Yes. Not the total opposite, just the middle signs opposite. You see what I'm saying? Because here it's 2 minus 4i, so we change it to plus 4i. All right, y'all decide. One more. Decide amongst yourselves quickly. 5, 4, 3, 2, 1. All right, which one? I hear 17, 18, or 19. Y'all decide.
15.
Call out 17 to me.
No.
All right, 5 plus I, top and bottom. Now let's distribute, okay? Up top, -10 minus 2i. And on the bottom, 25 plus 5i minus 5i minus I squared. What's negative I squared? Plus 1. How do I simplify that? Divide everybody by 2. -5 minus I. Buckle up. All right.
So much, so we only got like 2 minutes left.
Say again? Yeah.
Why we ain't need that?
Before the test. I'm on quiz. I'll look and I'll look. I think it's. There is. Today's Monday, Tuesday, Wednesday. Probably Friday, I'm thinking. Probably Friday. We only have 2 more lessons to do. And I've got your extra credit assignment too. It's the only extra credit assignment I do in any class at any point in time ever. And it's in Algebra 2 and Unit 1. Huh? I don't know. I'll probably run it for you. We'll do it in class the day before, but if you want it early, I can get it for you early. Okay. Okay. Yeah. All right. Let's talk about complete the square. Friday. It's supposed to be Thursday, but I think I'm gonna push it back to Friday. I've got it scheduled right now for Thursday, but I think it's gonna be Friday. Today, and we'll really practice with it tomorrow. All right, so before I talk about complete the square, let me rewind back. Remember I told you you didn't have to learn all those special patterns until we got to a certain point? This is the certain point. Welcome to the certain point. So let me just review PST with you really quickly, okay? And why we use PST. So you tell me what's a perfect square trinomial. The ends, what's special about the ends? They're both perfect squares. Give me an example of a perfect square, Cody. 4. I'm going to say 4x squared. Give me another example of a perfect square. 9. What else has to be true? The ends have to be perfect squares. What else has to be true? Plus sign second, but go ahead. Say what you were saying. There you go. Square, square, multiply, and double. So for this one, what would need to be in the middle to make this a perfect square trinomial? Close. 12. Why is it 12? 2 times 3 is 6, and 6 doubled gives you 12, okay? So we have to be able to recognize these perfect square trinomials. Now, if it's a perfect square trinomial, that means I can easily factor it. How does this one factor? Two x, and then the first sign, which is plus. Do we all agree? For this one, you're going to have to be able to do it this way, and I'll show you why. That's right. Square roots multiplied and doubled. All right. Now, that's thing 1 you have to remember, okay, about the perfect square trinomial. Thing 2, if I am solving, and there was a question like this on your quiz that a couple of you really stumbled over. If I have something like x plus 1 squared equals, I don't know, 5, and I have to solve it, You need to take care of the squared first. I don't want to FOIL this. How many times? Equals what? You can't, why can you not distribute this? Okay, that would be FOILing, but there's an easier way to do this. Just square root them. Right? X is only there one time, so I can square root. So x plus 1 Sure. So if there was a 4 here, that would become a 2 then once you ask. Yes, you can. Yes, sure. Yes. It would become 2 if you square root it. Or you could divide both sides by 2 first. All right. So, listen. All right, so this is why if you look in the red where I started, right, that looks like an already factored perfect square trinomial. Yes, it was already factored that way. So, yeah. No, this is a set. This is thing number 1 I needed you to remember, and this is thing number 2. Yeah, sorry. Outside the radical. All right. Y'all stop stressing. All right. Now, we're going to take these two things and combine them. But before I do, I want you, yeah. Don't cry. It's only worth 18. Are you saying if you make less than 100, you cry? All right, listen. I don't know. What do I need to put in the blank to make this square dance? Or to make it? 10? 10's not a perfect square. 100. Okay, look. How are we doing this? Because this is going to be the key to completing the square. I'm not going to give you homework tonight because I'm not going to rush anything through on this one. But I need y'all to pay attention with me and stay with me through the end of this, okay? Because I'm just going to introduce this. We're just dabbling our toes in it right now. All right. Y'all said 100. Why is it 100? X 10 multiplied and doubled gives you 20x, okay? Let's try another one. Because now what we're going to, I remember I told you we'd come back to perfect square trinomials. We're back because we're going to use them to solve quadratics a different way. How are you getting that? Are you working some kind of magic over here? So does everybody see what we're doing to cause this to work? Okay, we're forcing a perfect square trinomial is what we're doing. So in other words, essentially what we're doing is we're taking half of the middle term, and I'm going to call this a C, a good C. Remember how we have ax squared plus bx plus c? A good C is going to take half of the middle. This is assuming the leading coefficient is 1, which is what we'll talk about why it's always going to be 1. But it's going to take half of the B in the middle and then square it to go here. And if I do that every time, I'm going to end up with a perfect square trinomial that's going to be an easy factor. How does this one factor? 1x minus 4 squared. Okay, there in the blank, I'm trying to come up with a number that's going to make it square dance, right? So whenever I take the square roots of the ends, put them together and double it, I get what's in the middle. So I'm kind of undoing the put it together and double. So instead I'm dividing by 2 to undo the double, right? And then squaring it undoes the square root. So there, and since the first one's 1, I don't have to worry about anything. So to undo that whole thing so that I can find what it needs to be, I divide the middle one in half and then square it to put it on the end.
And that is what that is.
That is what that is factored. Okay? Okay. That's right. A lot of people can just look at it and find it, and you don't need the formula, but if you like a formula, there's a little formula for you. Okay? Let's do another one. Where the what? That's how it factors. When all that is in play and that all works, you do the square root of the first and the square root of the last. The very first sign is the one that goes in the middle. And that works every single time. We're forcing it to work is what we're doing. So whereas before we were looking for a perfect square trinomial, now we're writing it to make it a perfect square trinomial. Okay, and then factoring from there, yeah. We would have to take the 5. We would divide everything by 5 before we start. We'll talk about that whenever we get to solving. I want you to find the good C that would go there and then factor the trinomial. Think you get it? Don't say it out loud. Yes. Same way we did here with the parentheses and squares. When you divide it by 2, that's exactly right. Y'all ready for a challenge? One more easy one, and then we'll do a challenge. So it's the square root of the first, and then the square root of the last. Give me an even number. Give me an even number. Yes. 76. This is the last easy one. Find the C that makes it work and then factor it. This one's harder. Ella came up with a huge number. I know, and you can do it. Yeah.
Good morning, Camden High School. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please be seated for a moment of silence. Congratulations to the following ninth grade students who are part of this year's Student Council. President, Jalea Bracey, Vice President, Sanaya Cook, Class Representatives, Riley Grace Birch, Lexi Gatto, Lily Mae Hall, Kenya Johnson, and Kanaya Lee. This week is Camden versus LE Rival Week. Check out the posters in the hallways to plan to participate each day in Spirit Week. Today is Guess the Game Score contest during lunch. Enter the contest for a chance to win a gift card. Tomorrow is the Flip Cup Challenge during lunches. On Wednesday, August 23rd, Hot Rod Ice Cream will be here during 4th block. They offer a variety of delicious ice creams and popsicles. To purchase your ice cream or popsicle, go to the library to pay. You will receive a ticket that you will present as proof of purchase. The cost is $3 for ice cream and $2 for popsicles. Participate in this event to support the Bulldogs during Rival Week leading up to the big game against Lugoff. Thursday is Tacky Day, wear LE red and blue. Friday is Spirit Day, wear your gold and black. Pep Rally will be held during 4th block. Shirts for the CHS versus LE game are on sale in the library. Don't wait until the last minute to get yours. Cost is $15. Attention seniors, today is the order deadline for early delivery of graduation materials. Desasor Tri-High Y is back. If you're interested in becoming a member, please see Ms. McGee in room 600 for an application. Students who are interested in joining the Spirit Club should go by the library to sign the interest list. The first meeting will be on Wednesday, August 23rd during the last 10 minutes of each lunch in the library. The first unified meeting will begin after Labor Day. Attention members of the swim team, today's practice is canceled. Fall sports passes for students can be purchased in the Wellness Center for $20. The passes cover admission to all fall sports events. Congratulations to varsity football on its 43-0 shutout of Myrtle Beach on Friday night. Advanced tickets for Friday night's game versus LE